very diverse and experienced set of panelists today, and a very interesting topic to discuss. As the moderator kind of mentioned, it's about sustainability versus AI. Is a clash of convergence. Now, to demystify that, the clear question we're looking to address is AI a solution to the sustainability problem, or is it part of the problem? And to get us kicked off, let me just demystify what we mean by that, right? AI itself, and in fact, today, Gen AI is the buzzword, is seen to have a lot of potential. It's seen to have potential to effectively optimize resources, reduce waste, reduce our energy consumption, optimize it, and drive a lot of value. But on the other hand, AI also has a pretty large carbon footprint. In fact, not many of you may not know, but an AI like GPT-3, which was the precursor to ChatGPT, effectively consumed almost 500 plus metric tons of, or emitted 500 plus metric tons of carbon, even when it was being trained to perform. And even while it's performing, that's basically addressing queries, it consumes about 8 metric tons of, or rather emits about 8 metric tons of carbon per year. And that's just GPT-3. And ChatGPT is probably more than 10x in terms of compute capability. GPT-3 had about 200 billion nodes, whereas ChatGPT has about 1 trillion plus nodes. So it's an order of magnitude higher. And given that, while there's no clear measure or there's no requirement to provide sustainability reporting for these AI or large language models, but that itself is substantial based on the data points that we have. So it's quite a significant issue from the perspective of the carbon footprint of large language models. So given that that's the pro and the con, wanted to see where AI stands in relation to sustainability. So effectively, there can be 3 answers to the question. One is AI is part of the problem. Second is AI is actually a solution to the problem. Or the third is you're undecided. So wanted to take a poll of our panelists and the audience today for each of these questions. So a quick old-fashioned show of hands. Is AI a solution to the sustainability problem? Please, show of hands, please. All right. And is AI a part of the sustainability problem?
Right now it is.
All right. Lot more hands. That's interesting. And how many people are undecided? I think a majority of them are undecided. All right, fantastic. So let's, we've got a very short amount of time to do justice to this topic, but we'll get started. In fact, I would start with Sandhya, ladies first. So definitely want to know where you stand on this topic and why. And overall, what do you see is required to actually make AI a lot more relevant and at least change the minds of the people about the potential for AI to address sustainability?
Thanks, Suraj. And let me try to change the mind of people if they haven't decided or they have already made up their minds. So before I get into the question, let me start with mentioning that Schneider Electric has been named #1 as world's most sustainable companies in 2024 by Times Magazine and Statista. And this recognition, this global recognition, reiterates our commitment towards sustainability and the kind of ambitious goals that we have signed up on this mission. And most importantly, how we are helping our customers to lower their energy emissions. So how are we achieving this? So we have our electricity 4.0 strategy, which combines or which couples the forces of artificial intelligence, digitalization, and electrification to make sure that we are reducing our own emissions as an organization and at the same time also helping our customers achieve their sustainability goals. Now, having said that, going back to the question, so what we have seen over a period of time is 80% of the CO2 emissions are related to energy, and out of which 45% are on towards the energy generation side, and surprisingly, the remaining 55% are related to the demand, right? Where we believe that consumers play that pivotal role in making sure that we lower those energy emissions. Now, having said that, as an organization, we believe that AI is going to be a catalyst for achieving the sustainability. Why would we say this? Broadly from three aspects. One, how do we reduce the energy usage, right? And how do we bring in the right AI tools so that we are able to optimize the energy usage? Second, we believe that the time has come for transitioning towards electrification, getting into more green electricity, getting into more renewable energy sources. While that transition happens, at the same time, how do you leverage the right AI tools so that you're again able to optimize the energy usage? Gone are the days where we are just talking about consumers, right? There is this new term which is coming in that you're consuming the energy and at the same time producing the energy, right? So prosumer. So that's the second aspect that we believe which AI would play an impact, would play a critical role. And third most important thing is about predicting the demand generation and how well we take those smart decisions using the right tools in place. Now, having said that, as we believe AI is a catalyst for sustainability and its key role, we also have to look at the other dimension of sustainability on AI, because AI would need more high compute power, and there is an impact on data centers, right? And as you rightly mentioned, every single point usage of AI algorithm for CO2 reduction, carbon footprint reduction, how much is it, or AI algorithm introducing carbon footprint, how is it reducing the carbon footprint across various devices? So that is as well the other dimension that we have to look at. So all in all, there has been a good study and the good results that we have seen in terms of AI being a catalyst for sustainability, but there is a lot more work that our data scientists are working on in trying to bring in some mathematical equation, if possible, in terms of how much we are introducing through AI versus how much we are trying to reduce. So a lot more to come, and that will help us to be more responsible AI organization.
All right, and a quick follow-up. What sort of pitfalls or challenges do you see in actually adopting AI at scale from your perspective?
One is about having a robust AI platform, right? And of course, the right skill set that we need as an organization. And second thing is about as an organization, how do we understand the drift of the model and how do we take care of that? So these are the two major things that we look at it.
All right, okay, thank you. Himanshu, over to you. I thought you took a position that AI is part of the problem.
Yeah.
All right, that's interesting. So why do you take that position, and could you please enlighten us?
It's a great point, actually. So, means I am talking about right now. Right now, AI may be a part of a problem, right? Because, when we talk about, sustainability with AI, and whether it's the clash or convergence, right? So right now it's a complex interplay, right, between clash and convergence, right? AI algorithms typically are energy intensive, right? They require tons of energy to get trained, to get deployed, right? As a matter of fact, on a daily basis, GPT-4 algorithm requires around 500,000 units of energy, right, for 200 million queries. Right, and when we talk about GPT queries vis-a-vis Google search, right, they consume as much as 15 to 20 times more energy, right, when we convert to when we talk about traditional Google search kind of thing. Now, these things are having a quite high carbon footprint, and I'm not even talking about training of these algorithms, right? Another level, right? And apart from that, you need GPUs to train these kind of model and serve it, right? And that's a complete different ecosystem. You have to mine the silicon, right? You need to convert those silicon into chips, right? And then convert into a equipment, right? So, and then there is a replacement cycle, right? 6 years, 7 years, you need to do the replacement for these chips. So that kind of carbon footprint right now I'm talking about, right? And apart from these algorithms runs on data centers, right? Typically a capacity of data center we talk about in terms of megawatts, right? So all over world presently the data center capacity is around 30 gigawatts, right? In India it is around 1 gigawatt or sort of thing, and it is expected that after 3-4 years, it will increase up to 75 to 80 gigawatts, right?
Yep.
Worldwide, right? Now, this is the power requirement of small to mid-sized country, right? That AI is going to consume over the period of next 3-4 years, right? And one important part we have skipped, right? When you run these algorithms on data center, right? A lot of heat is generated, right? Now, you need clean water, right? To take away these heating problem, right? Now, a typical data center of 50 megawatt requires around 5 million liters of water, pure water per year, right? And if I see from extrapolation point of view, in the next 3-4 years, right, this requirement could be 6 billion cubic meter of water every year for 80 gigawatts of data center. Now, this is again the water requirement of half of UK per year. So, this AI workload are acting as a country, small to medium-sized country in terms of resource depletion, right? Now, when I talk about sustainability, right, AI is having a high potential, right, to achieve the sustainability, but I am using the word potential here, right, because where it matters, right, in manufacturing, in energy, transportation, agriculture, right, or even construction, right, infrastructure development, right. I have not seen much of a penetration of Gen AI, right? It has been adopted in software development, image generation, text completion, BFSI, right? When you talk about sales and marketing, right? The penetration is good. But in this core sector, which is a backbone of a country's development, the penetration, there is a potential, but it has not been penetrated yet, right? So that's why right now there is a friction, right? But going forward, I am hoping, right, if these AI algorithms, these LLMs are being adopted to their true potential where it matters, right, then it will be a convergence.
All right, that's interesting. So thanks a lot for that perspective there. So it looks like it's clear that the carbon footprint and the carbon cost is real, but the potential is still just potential. It's got to be realized, and we have work to do. That context, I'll come back to you on that and talk a little bit more about how we can address that. But let me go to Raghu and get his view on this. I didn't quite catch where you stood on the matter.
Sure. So I didn't raise my hand.
All right, that's good.
So I think the data that we have shared in this forum is quite interesting, and the impact of Gen AI and AI in particular, but I think more in case of Gen AI, in terms of the energy consumption and its associated emission and the CO2 impact on sustainability is there. It is real, right? And all the data is available. Just to run a large language model, they are saying it will be close to around 1.2 million units of electricity or the heat generated is consumed, and it's almost like 100 to 150 home electricity in a year. So that much of energy is getting consumed there, and associated carbon emissions and all of that is happening. I think we need to look at the problem in two segues. Number one is, by using AI, are we really optimizing energy, and energy in an indirect manner also, right? So if you look at today, the smart grids, I think Schneider Electric is working on many of the smart grid solutions. Smart grid solutions, when you are looking at distributed energy management grids operating under wind turbine, solar, and battery storage at home, and all of that. We worked with an Australian utility company, which is in a pilot project for 1,000 homes in Western Australia, where there are solar power plant, there is a storage that is there at their home, and there is electric vehicle, and there is a microgrid operating. And the demand grid and as well as the supply has to be managed very accurately on a real-time basis, and so that it can really, some solar is more, it can feed to the battery storage, or sometime it draw from battery storage, or sometime it draw from grid or pass to the main grid. Everything is operating on an AI algorithm. So you are able to really achieve a balanced DERMS system, because in the absence of AI, we will not be able to achieve that level of efficiency. And we are able to achieve this. And if you take industry after industry, for example, an automotive unit, power plant, or a large building, today by adopting AI algorithms to optimize the energy usage, you are able to save sustainable electricity by almost 15 to 20% in all these cases. We worked with one of the Japanese power plant. It's thermal power plant, it's still conventional, but even there, the problem is to reduce the fuel consumption and also the SOx, NOx emission. And the way we could actually apply AI there to control the boiler parameters, we could actually achieve the emission level at the right below the threshold, as well as the heat rate and efficiency at the optimal level. And which is great, because you can't achieve that without that algorithm. Otherwise, it's trial and error by the operator. So I think supply chain, tracking and movement, across sectors, AI can impact the energy consumption, reduce it, make it efficient. But if you flip back to the other side, I will leave it with 2-3 points. I think the large data center power consumption is an issue. So today people are looking at technologies that by which they can reduce it, like liquid cooled data centers, and the SoCs, system on chip, that is running the AI algorithm. Like today, the NVIDIA's getting the one that is in production is Hopper, but then one which is coming now is Blackwell, and they claim that Blackwell will be at least 30% energy efficient. So I think by addressing the compute, and also federated AI compute is another area, there are measures like that, and taking very small LLMs rather than high level of LLMs. Those are all ways we can reduce the energy consumption in AI, and not just say, okay, AI is very energy polluting, so I will not go for it. And I think we have to, this kind of things will keep balancing. And there could be potentially disruptive compute methodology also that could be coming back, like polymorphic computing they are talking, or quantum they are talking. It's far away, but I think the potential, we have to increase the research on those areas as well.
Right. Yeah. Thanks a lot, Raghu. So at least some optimism there, and some real life examples of where AI can make a difference in driving optimization. But there was also an interesting point that you brought up, Raghu, is I guess for the firms that are deploying these large language models, getting them to actually report on the carbon intensity and showcase how they can actually drive down that carbon intensity is an interesting topic. And that's something I'll come back to, Himanshu, but I just wanted to talk about my point of view on this as well. So I'm on the side of the optimism on the value of AI in actually doing good for sustainability. And that's because of what I've seen per se in the work that we do. At Quest Global, we are a pure play engineering services company. So we actually help with product development and infusing AI into products, etc. And some of the examples I've seen where, say, if you take an ultrasound machine, AI actually providing real-time insights on where the anomalies are and identifying those kind of anomalies and helping identify danger to life and situations, etc. For people who are just operating, those things are invaluable. Invaluable in the sense that AI is not replacing human effort. It's actually doing something that people couldn't do earlier. And similarly, same concept being applied to defects in aircrafts, where humans were doing it earlier, probably error-prone, tedious work, and again, critical to saving human lives. So these are areas where AI is kind of actually proven to deliver value, but granted, it's not at the scale. There are certain areas where it's delivering value, but a lot of the use of these large language models is to answer generic questions that people just like to throw at it.
Yeah.
And that's a huge waste of carbon, of precious carbon resources, right? Or emissions that we can avoid. So from that perspective, we still need to do a whole lot. And so with that, let me come back to you, Himanshu. You kind of are at the forefront of bringing in a lot of the green energy, right?
Yeah.
And we have always talked about the carbon footprint of large language models with the assumption that a lot of that energy is consumed using fossil fuels.
Yes.
So any thoughts about what Raghu was talking about, getting the data centers to actually become green themselves and not be so carbon intensive?
Yeah, so it's an right question to ask here, because means we are in the business of sustainability, because we are generating green energy, right? But to become the sustainable business, we need AI, right? It's a paradox, right? Because means when we are generating solar or wind energy, right? They are dependent on sun god and wind gods, right? So you need to know what kind of solar radiation or wind speed you will be getting at a particular location for 25 years, for the next 25 years, to get the viability of the business itself, right? Because you need to run the business at the end of the day, right? You need to be profitable. So you need to ascertain that over the period of 25 years, what will be my power potential capacity, right, at a given location. Here, in Adani, we identified that 3 years back, right? And actually, when we talk about AI algorithms, right, alone AI algorithms cannot run. Means they will run, but it will not be an optimized output, right? It has to be combined with some sort of sciences. So what we did, we combined AI with weather and climate sciences, right? And then we were able to predict what kind of radiation, right, by climate change studies and implementing AI on top of that, what kind of radiation changes will be happening over 25 years. And we were around 98% accurate, which was very high, right? So that is solving the real business problem, right? And when you construct the business, right, you need to do supply chain management. You need to reduce your turnaround time, right? You need to minimize your inventory, right? You need to reduce your interest during construction part, right? Here AI is helping us out to optimize all these aspects. And when you are running a plant, right, you are feeding energy into the grid, then you need to maximize the generation, right? So we have created a AI-based digital twin which maps the present baseline performance in real time and tells where is the issue, right? Solar plants are very big, right? 1 megawatt is around 4 acres. So a 100 megawatt plant is for around 400 to 500 acres, right? You cannot go just there manually and identify the issue. And it has to be automated, it has to be AI driven. We are doing that kind of stuff, right? And then we talk about green energy. So typically what happens with the green energy, although it's a clean source of energy, right? But the reliability is on a lower side, right? And as a matter of fact, in India, around 100 gigawatts of renewable energy is there, right? Around 60 to 70 gigawatts is solar and around 30 gigawatts is wind around, right? Now, this solar energy is not available during the night time, right? So you need some proper battery storage or some sort of storage to provide round-the-clock power, right? Because these data center requires 24/7 power, right? With some sort of backup. So what is the strategy for that, right? And typically, if you talk about 100 megawatt data center, right, you cannot just put 100 megawatt plant, right? It has to be more than that because plant is not operating at full capacity, specifically renewable plant, because wind will be, unpredictable. It cannot be blown at the rated speed all the time, right? And the radiation will not be coming all the time, right? So that kind of issues are there. So the idea is to frame a policy like that with proper storage system that can provide round-the-clock green energy to the data centers, right, to make it green. And then water storage, water issues, these kind of challenges are also there that we need to think about, means how to do.
Right, right. So thanks for that. So effectively taking away that there has got to be some policies that would ensure that the carbon intensity of these data centers is minimized, right?
Yeah.
So certainly. So let's talk about actually trying to extract value from AI at scale. So from that perspective, Sandhya, where is your company and your work? Where do you focus on? Do you look to drive it within your company? You talked about sustainability within your company using AI, or I don't know whether you're using AI there, but then do you apply it there, or are you applying it to your customer offerings as well to realize the value of AI?
Yeah. So before going into the question again, as the previous panelist said, it's so fascinating to get started into the solutioning mode, right? Just get AI and then look for the problems. So what as an organization, the conscious effort that we have taken is to start with identifying the problem that we want to solve. It can be the internal problem, very specific to Schneider in terms of improving our productivity or any other efficiency at the factories, or pick up a customer problem, right? So that's the approach that we have taken. And in line with that, we made certain changes in the way we operate, and we have defined an AI hub and spoke model. Right? So what we want to leverage through this model is we have about close to 400 plus data scientists across the globe working for this AI hub who bring in that knowledge about algorithms and which algorithm when to use, that kind of know-how. While at the same time, we have the business teams who bring in that domain knowledge in terms of identifying the problem statements. So bringing in these two teams together, we try to brainstorm on what is the problem that we would like to solve. So that's one. The second thing is about, as Himanshu also mentioned, we don't want to launch just the standalone AI tools, right? Because it's going to be a burden for our customers, or it would end up being one another tool for the customer to operate and maintain. What we believe as an organization is, how do you embed this AI tool as one of the feature in the existing product itself? So that's extremely important to solve a problem at hand, and also move up as a scale, AI at a scale. So these are two things that we are, as an organization, we are very conscious about. Now, what we have done over the past 3 years is couple of use cases that we have identified both for our internal and external. So some of them, to name a few, as you again have mentioned, there are a few examples where we have very good success stories, and few of the areas where we are still revisiting our strategy in terms of what kind of a different approach that we have to take. One such example is about, again, internal example is about our the concept of the self-healing supply chain management. We have an AI tool that will help us to balance the inventory, looking at the projected demand coming in across the plants. That's one example where we have seen a very good success story. The second success story that's in the making is about the prosumer, right? We spoke about in terms of moving towards the green energy, leveraging AI to understand what is your typical energy usage and how do you manage those demand spikes, and then take a conscious call if you want to use the energy from the grid, or continue on, store the energy and then continue on a battery, or if you have a surplus energy, why don't you, sell it back to the grid, right? So this is also another area where we are seeing definitely some, a good story in making. And this is again making our buildings also more smart. And as we speak, one of our site in France is almost at carbon net zero, right? In terms of
Congratulations.
leveraging the green energy plus AI algorithms, this is making this mission happen for us. Apart from these examples, there are always some improvements that we see in terms of introducing some of the conversational AI tools that will help us to answer some of our employee queries. Again, these tools, AI tools from the answering the customer queries mainly for a customer care representative. Also, we have launched some of our platform software wherein the Gen AI is embedded, which this is called EcoStruxure Resource Advisor Copilot in collaboration with Microsoft Azure. And this is really helping us to give us some additional insights about the visual dashboards, giving that constant optimization hints back to our customers. And these are some of the nuggets that our customers are looking at. And towards the end, some of the improvements that we have seen in terms of how we address certain queries, mainly from an accounting standpoint. So all in all, there is a roadmap. Every product has a roadmap in embedding AI as a part of their solution. And we are definitely gearing up there and seeing some good success stories.
All right, that's good. So there's a lot more happening, at least in favor of AI helping sustainability. That's great to hear. Raghu, from your perspective as a system integrator, you probably have a good role to play in starting to deploy the benefits and impact at scale. So how are you viewing actually helping AI contribute to sustainability?
No, I think if you really look at today AI, we can classify the usage in two major dimensions. One is just improving some incremental automation and efficiency and providing chatbots and those kind of things. The other is that is actually completely disruptive. Things that we have never imagined, never thought that we could actually address, can be addressed. And I'll give just as, I know we are left with only 3 minutes, so I will give only one example here. For a utility company in North America, in California, one of the biggest problem in each summer is the wildfires, because they are running their transmission lines through the hottest part of California, and invariably the transmission, weather conditions, temperature, wind speed, and if that trees come and get in touch with those transmission lines, you get it fires and it affects the counties, and they have to pay millions of dollars as damages. More than the dollars and damage is the disruption that is caused to the life of many of the people and their consumers. A very simple AI solution that was developed with this customer actually is take the weather data that is anyway coming well in advance, maybe a week, and getting more accurate by the day, and the wind speeds and the kind of combinations of, let us say, from the GIS data, you know what counties will have a worst weather condition combinations. We could predict these are all prone counties for wildfire during these days. And those days, the utility will inform the consumer that you will not get power during this daytime in these hours. We will be shutting down the grid because there is a risk of wildfire. It will go, communication will go, and field services will also be informed. They could actually reduce the amount of field fire incidents by almost 50% by this solution. And this is AI not for efficiency. It's not AI for any incremental chatbot answering here. This AI takes data from multiple sources, weather data, GIS data, past history, whatever it could, and put a probabilistic model, and we are just taking a precautionary step for those wildfires. I can actually list number of applications that would be very disruptive for the industry itself that we can build through AI applications. And time is short here, but I think you get a flavor of where we are heading with it.
Thanks a lot for that, Raghu. Yeah, definitely. Time is short, so I'll thank you very much for that. In fact, that's a great example where you're actually able to deploy AI in a disruptive way to avoid a huge amount of carbon emissions, right? So clear examples of potential that can be realized and realized at scale going forward.
Yeah.
So to summarize the discussion, what I've taken away for the benefit of the audience is, when it comes to AI, there are quite a lot of potential, but the potential has to be applied in the right direction where there is value. And clearly, there needs to be mechanisms to ensure that the value can be deployed at scale on the right problem statements.
Yes.
So some of the examples that Sandhya gave about having a hub that can provide the excellence and having groups that can actually help with deploying it, etc., might help us find those right problem statements and solve them. And that's a way to actually derive greater value for sustainability from AI. But there's also the other bit that AI can't have an unfettered ability and freedom to pollute. And so from that perspective, clear policies, clear governance and reporting, and ensuring that these data centers leverage clean sources of energy rather than fossil fuels is also required, because that's clearly a certainty which we need to ensure is optimized as well. In fact, use AI to optimize the consumption of AI itself, if possible. All right. So that's the key takeaway here. We probably have time's up, but we probably look to take at least one question from the audience if we have any questions.
Seeing a hand.
Yeah, we have a question here. Could we have the mic to them, please?
Thank you. So my question is more towards the timeline that Himanshu kind of touched upon. The transition towards currently the AI is kind of problem, right? When do you think it will become a non-problem or more towards a betterment of it, right? So considering our history from all the industrialization to currently we are talking about renewable energies and all the electric cars and everything, it took almost half a century. But currently we have like billions of minds connected with all the globalizations and technology advancements. So considering all this transition, from your opinion, how much time it would take, roughly?
Yeah, this transition has already happened, right? It has started to happen, right? Means when I talked about a brief history of AI, right? It started around mid-60s, 70s. Then there was a huge gap in between, which was called AI winter, right? Now with the advent of the available data and deep learning technologies, that started in around 2009-10, right? With the advent of LXNet, which was a convolutional neural network for deep networks, and then generative AI, which got introduced in 2015 and 16, and last year, this GPT thing, right? Now this transition is very rapid, right? Because what is happening, right? Because this at the scale of globalization that we are talking about right now, at the pace with which the technology is changing over the period of time, we have started to see the changes AI can impart on productivity in driving efficiencies and sustainability. And right use of the AI for the right use case, right, is the key to drive sustainability through AI.
Yeah, my question is more towards AI is consuming a lot of energy right now, right? So that when do you think it will change? Let's say today we are using a lot of energy to use the AI. So when do you think it will become a very less amount of consumption to deliver the same amount of output or even better?
It's a hard question, right? So when we talk about AI, so LLM use, the parameters consumed, because it's basically a matrix multiplication. Right. When we talk about AI, right, it's a glorified matrix multiplication, right? Many matrix multiplications are happening behind the scenes. So the idea is there are 2-3 research area, right? First, you can use quantized weight, right? Instead of using 32 bits weight, you can use 4 bits weight or 8 bit weight, right? It will reduce the energy. And then there are state space models that are coming into the picture. So research is happening in this field. But the scale, we are developing the AI right now. In the coming next 3-4 years, it is not going to happen, right? These things are going to, take more and more energy over the period of the time, because the use case will increase, right? The API calls to ChatGPT is going to increase over the period of time in the next 3-4 years as we are adopting the AI. But research is going to happen right? It is happening right now, and we will see that next 6, 7 years down the line, it may start to come down over the period of time.
Okay. Sorry, just a last one. So getting the AI companies to become more open source toward whatever they are developing will kind of support in doing this transition quicker rather than everybody developing a different AI, LLMs on their own or doing it on their own. Getting whomever is developing it, make more open source will solve this problem somehow?
No, actually, I think we probably are stating the problem. The data center consumption today is 1% of global entire energy that is getting generated from various sources. If you are already applying AI to optimize the 99% of the energy generated by DERMS and many other methodologies to even save 5%, 10%, this 1% of the data center consumption that we are discussing here is actually is not material. So that is not a big issue. Yes, there is an energy consumption issue in data center, but you need to weigh that against there are energy consumption that is happening across your plant, across your many other industrial transportation, which is going to be saved by AI. Let's say 10% you are saving. That will offset all your data center problem. So let us not get overstated. It is a topic of this panel, so we are giving all the points for you to consume.
All right. So on
Just
that
to
note,
add,
actually,
to add further,
so maybe we can do another quick show of hands.
I'll just complete.
We got to wrap up.
Yeah, I'll just complete.
Sorry.
Yeah. Even that 1% that we are talking about, Schneider Electric being predominantly into the energy management side, we are looking at every component that every product or solution that gets into the data center segment. We are looking at what kind of efficiency improvements that we could look at every product so that even that 1% or 0.5% improvement in the energy efficiency would really boost that, even that 1% additional that we are consuming, right? So.
All right, so we'll do a show of hands again. Again, 3 options. AI is part of the solution to sustainability. Show of hands, please. All right, a lot more show of hands now. AI is still a part of the problem. All right. Some die-hard pessimists, and how many undecided people? All right, very few undecided people. At least
It's a good sign.
forced
It's a
a
good
certain
sign.
position. All right.
It's a good sign, actually.
All right, thank you very much.
For more content on tech and leadership, subscribe to nasscom YouTube channel and press the bell icon to never miss an update.